Space exploration has always captivated humanity. We look up at the stars and dream of reaching out and touching them. In the past, our journeys to space were one-way trips. Rockets, after propelling their payloads into orbit, would fall back to Earth, burning up in the atmosphere. Today, however, a new era of space exploration is dawning, one marked by reusability. Rocket-catching technology is revolutionizing the way we explore the cosmos. It allows us to recover rockets after launch, enabling multiple uses and dramatically reducing the cost of space travel. Imagine a future where rockets are treated like airplanes, taking off and landing with remarkable precision, ready to fly again. This is the promise of rocket-catching technology, a game-changer in our quest to explore the universe. Vertical landing is perhaps the most visually stunning method of rocket recovery. It captures the imagination and showcases the pinnacle of engineering prowess. It involves guiding the rocket back to Earth in an upright position, a feat that requires precise calculations and flawless execution. The rocket must land gently on a designated landing pad, which is often a floating platform in the is a testament to human ingenuity and the relentless pursuit of perfection in space travel. Mid-air capture offers another intriguing approach to rocket recovery. This method involves using a helicopter or a specially designed aircraft to intercept a descending rocket in mid-air. It's like catching a fly ball in a baseball game, but on a much grander and more complex scale. While still in its early stages of development, mid-air capture holds significant potential for recovering smaller rockets, or even individual rocket stages. One of the primary advantages of mid-air capture is its ability to recover rockets that may not have the fuel reserves for a powered vertical landing. This method also reduces the need for large landing pads or drone ships, potentially making rocket launches and recoveries accessible from more remote locations. Parachutes, a time-tested method for returning objects from the sky, are also playing a crucial role in rocket recovery. While not as flashy as vertical landings or mid-air captures, parachutes offer a reliable and relatively inexpensive solution, particularly for smaller rockets or upper stages. Think of the graceful descent of a dandelion seed floating on the wind. Modern parachutes used in rocket recovery are far from simple pieces of fabric. They are complex systems designed to withstand the extreme stresses of atmospheric re-entry. These parachutes are often made from high-strength materials like nylon or Kevlar, and are carefully packed to ensure proper deployment. Section 5. Building a rocket catcher, engineering marvels. Developing and implementing rocket-catching technology is no small feat. It involves a series of complex challenges that must be overcome through innovation and collaboration. It requires the combined efforts of brilliant engineers, innovative designs, and a deep understanding of physics and aerodynamics. Each team member brings their unique expertise to the table, ensuring that every aspect of the project is meticulously planned and executed. This technology is a testament to human ingenuity, pushing the boundaries of what's possible in aerospace engineering. The successful recovery of rockets not only demonstrates technical prowess but also paves the way for more sustainable and cost-effective space exploration. The process begins with meticulous design and simulation, ensuring that all components work together seamlessly. Engineers use advanced software to model every detail, from the aerodynamics of the rocket to the stress points on the landing legs. Every detail, from the size and shape of the grid fins to the strength of the landing legs, is carefully calculated and tested. These components must withstand the intense forces experienced during launch and re-entry. Manufacturing these components requires the use of advanced materials and precision engineering to withstand the extreme conditions of launch and recovery. The materials used must be both lightweight and incredibly strong. The development and implementation of rocket-catching technology require the expertise of skilled engineers and cutting-edge manufacturing techniques. This collaborative effort ensures that each rocket can be safely recovered and reused, marking a significant advancement in space travel. Section 6. The financial benefits of reusable rockets, saving money and resources. One of the most significant advantages of rocket-catching technology is its potential to drastically reduce the cost of space exploration. Traditionally, rockets were expendable, meaning they were used only once, resulting in enormous expenses for each launch. Reusable rockets change the economics of space travel. By recovering and reusing rockets, companies can significantly lower the cost per launch, making space more accessible for research, communication, and even tourism. Imagine the possibilities if we could travel to space as routinely as we fly across the country. This graph illustrates the significant cost savings achieved through reusable rocket technology. Section 7. Environmental impact, a greener approach to space travel. Beyond the economic benefits, rocket-catching technology also offers a more environmentally friendly approach to space exploration. Traditional rockets, upon re-entry, would leave debris scattered across the planet, potentially harming ecosystems and wildlife. Reusable rockets minimize space debris and reduce the environmental impact of space travel. By landing rockets safely and recovering them, we limit the amount of debris left in orbit or falling back to Earth. This responsible approach to space exploration ensures that future generations can continue to marvel at the wonders of the cosmos. Reusable rockets significantly reduce space debris, promoting a more sustainable approach to space exploration. Section 8. Challenges and future innovations, AI takes the reins. While rocket-catching technology has come a long way, challenges remain. Atmospheric conditions, technical glitches, and the sheer complexity of the recovery process can pose significant hurdles. However, ongoing research and development promise even more innovative solutions in the future. One area of active research is the development of AI-guided recovery systems. These systems can analyze vast amounts of data, make real-time decisions, and autonomously guide rockets back to Earth with even greater precision and safety. Imagine a future where rocket landings are as routine and uneventful as airplanes landing at an airport. Advancements in artificial intelligence are poised to revolutionize rocket recovery systems, making them even more autonomous and reliable. Section 9. A new era of space exploration, reaching for the stars, sustainably. In this chapter, we delve into the groundbreaking advancements that are revolutionizing our approach to space travel. Rocket-catching technology is more than just an engineering marvel. It represents a significant leap forward in our quest to make space exploration more efficient and less wasteful. It's a symbol of humanity's commitment to exploring the universe sustainably and affordably. This technology allows us to reuse rockets, drastically reducing the cost and environmental impact of each launch. By reusing rockets, we unlock new possibilities for scientific discovery, technological advancements, and even the potential for establishing human settlements beyond Earth. Imagine the breakthroughs we can achieve with more frequent and cost-effective missions. The dream of colonizing other planets becomes more tangible as we perfect these technologies. We can envision a future where humans live and work on Mars, creating new societies and expanding our horizons. As we continue to refine and perfect this technology, the future of space exploration looks brighter than ever. Each successful test brings us one step closer to making space travel a routine part of human life. The excitement and potential are palpable. Imagine a world where spaceports are as common as airports and space travel is accessible to everyone. Imagine a future where space travel is no longer a luxury for a select few, but a common endeavor for all humankind. Families could visit spaceports and children could dream of becoming astronauts as easily as they dream of becoming pilots. This is the promise of rocket-catching technology, a future where the stars are within reach for everyone. space tourism could become a thriving industry, opening up new economic opportunities and inspiring generations. This is the promise of rocket-catching technology, a testament to our unwavering curiosity and our relentless pursuit of the stars. Our drive to explore and understand the universe has never been stronger. With each innovation, we push the boundaries of what is possible. Rocket-catching technology paves the way for a future where space travel becomes an integral part of human civilization. It is a crucial step towards making our presence in space sustainable and enduring. As we look to the stars, we see a future filled with endless possibilities. Rocket-catching technology is not just about reaching new heights, it's about ensuring that our journey to the stars is one that we can sustain for generations to come. From vertical landings to mid-air captures, rocket-catching technology is paving the way for a sustainable future in space exploration. Thank you for joining us on this journey. For more exciting insights into the world of space technology, don't forget to like, share, and subscribe.